Today we are going to work on graphing quadratics in all the different forms that are possible. So to begin with, before we even start into the different forms, just looking at how do I graph something using my calculator. So I talked a little bit last week or so about sketching. So if we're expecting a sketch a graph, it's not going to be a perfect graph. All you're doing is you're using your technology, so you're going to put this into your calculator, and then you're going to find some of those key features. So think about those graphing characteristics that you would need in order to represent a graph. So some of those graphing characteristics might be x-intercepts. Another one would be maybe the y-intercept. And then because this is a quadratic, we're also going to be looking at the vertex. So those would be the three main graphing characteristics that you're going to need. X-intercepts, of course, we know the x-intercepts are the value of x when y is 0. So those sometimes might be a little harder to find, but you can find those using your calculator. You can use the trace key, you can do a calculate key. If they're really nice values, they're going to be in your table, like this one is going to be in the table. But otherwise, if you're not sure, you can always put in y equals 0, this horizontal line, and then do an intersection with them. For your y-intercept, what's really nice is when it's in standard form, your y-intercept always is negative 18, or go into your calculator, look at your table. What is the y value when x is 0? This one's always in your table. And then lastly, the vertex. So being able to calculate the vertex. So in order to find the vertex, you could try to trace it. You might be able to find it in your table. You might be able to find it based off of your x-intercepts, or there is a calculate button in your calculator. So I'm going to have you pause this and go through and find each of these pieces using your calculator. But the vertex is going to be second trace, and then you're going to go down to min. And then you got to give it a bounce. You got to give it a small x value to a large x value so it knows horizontally what you're looking at for your vertex. So pause this just for a minute and just find these key characteristics. Looking at some symmetry can help as well. So you know your vertex falls halfway between 3 and 12. So you learned that back in Algebra 2. But we did also exactly find our vertex, so I can go over 7.5, 10.125. And we're roughly close to that point there. And then the other piece is the symmetry, knowing that we have a parabola, so there's this axis of symmetry that goes through the vertex. So what you can look at, your y-intercept is 3 spaces away from your x-intercept. Therefore, 3 spaces away from your other x-intercept is also. So again, just giving you kind of some points to look at. So, connecting these. Oh, not so good with my drawer. But anyways, that's approximately what it looks like. Again, this is just a sketch. Did ask you also to list your domain and range. So your domain and range would be domain, x is an element of the reals, or you could say from negative infinity to positive infinity. And then for your range, so low value is negative infinity, high value is this y value here, which was 10.125. So from negative infinity, always go low to high. That one's included. Okay, so just getting you used to using your calculator, because you're going to want to be able to use your calculator for a calculator assessment. Now we're going to get into the different forms. We've already been focused a little bit on vertex form. So vertex form, you all should be familiar with. F of x equals a times the quantity of x minus h squared plus k. And then within there, it tells us automatically a couple of features. It tells us the most important part, which is why it's called vertex form, which is your hk. In Algebra 2, we called it graphing form, same thing. You know your axis of symmetry as well. It is an equation. Axis of symmetry is a vertical line, therefore it is an x equals, and it's always just the x value of your vertex, so x equals h. And then we can look at our stretch factor, which is always that a value. So we're going to find the coordinates of the vertex, find the equation of the symmetry, and then we're going to graph these as well. So my vertex, I'll give you a second, go ahead and fill out the vertex for each of these and then do the axis of symmetry. So here, it's a positive 4 and a positive 1. My axis of symmetry, therefore, is x equals 4. vertex here, the x value is -3 and -6, with the axis symmetry at x equals -3. Once I plot my vertex, now I look at my a value. My a value is negative, so it's going to open down. And then normally it goes 1 over when it's down, 1 down, but my multiplier is 3, therefore it's going to go 1 over and 3 down on both sides. And then typically it goes 2 over and 4 down. This one's going to go 2 over and 4 times 3 is 12, so -12 down. Again, that's from your vertex always. So that's just going to go one spot off my graph. Not ideal to extend a grid ever. You should change your scale, but for ease and just to give us some idea of where to head to, we'll toss those additional ones on there. If that was on a test, always change your scale. Okay, next one. So we have our vertex again at -3, -6. This one has a positive a value, so it's opening up. Multiplier is 2. So from my vertex, instead of going 1 over and 1 up, we're going to go 1 over and 2 up on both sides. And then instead of going 2 over and 4 up, we're going to go 2 over and 8 up. And then we could go 3 over and 18 up instead of 3 over and 9 up. Okay, that's a bad curve, but you get the idea. So again, just practicing with vertex form. Next, we're going to go into general form, also called standard form. They're used interchangeably. This is the way you would have learned quadratics to begin with. F of x equals ax squared plus bx plus c. So in this form, we talked about when you find your 2x intercepts, you can find halfway between the two, so then you can find the x value of your vertex. Or I could put this in and complete the square with it to solve it, or I could do the shortcut. And the shortcut is something maybe you just touched on and maybe you haven't seen it at all. But to find the vertex when it's in standard form, the x value is always the opposite of b over 2a. It actually comes from the quadratic formula. We're not going to do the quadratic formula yet. We're going to in a couple lessons. But the quadratic formula is the opposite of b plus and minus the square root of this mess all over 2a. So it's the opposite of b over 2a always gives you the x value. If you want the y value, you then have to plug in your x for your x's and get the y value out. Axis of symmetry, you can also always find really quickly. It's just x equals that x value, is the opposite of b over 2a. And then the other nice thing that standard form gives you right away is the y-intercept. The y-intercept is always your c value. Ooh, that's a comma. Because when I put in 0 for x, because y-intercept is when x is 0, so this is 0 plus c, so my y-intercept is 0c. So now you're going to graph these two functions based off of knowing that information. So we're going to find the axis of symmetry, we're going to find the vertex, and we're going to find the y-intercept. And then we're going to do that and graph it using points of symmetry. So one of the things to look at is you always know automatically the y-intercept. So I'm just going to list the y-intercept. Y-intercept, x is 0, y is -4. Again, it's always your c value. So y-intercept, 0, -1. So you automatically have 1 point every time. So now we're going to find the vertex. So I'll switch colors here. So to find the vertex, to find the x value of the vertex, it's the opposite of b, so -6 over 2 times a. So 2 times a is -1. So -6 over -2, which is 3. Now to find the y value, you've got to plug 3 back into your original equation and get your y out. So you're going to calculate f of 3. So f of 3 is the opposite of 3 squared, so that's -9 plus 18 minus 4. So that gives us 5. So therefore my vertex is 3, 5. Since I have my vertex, I know my axis of symmetry is at x equals 3. I think that's everything that they asked for. So now we're going to plot our vertex, 3, 5. And then it's opening up, it's opening down because a is negative still. But we know which way to go with this because we have our y-intercept here of 0, -4. All I need to have are 3 points to draw a parabola. So since this is my vertex, this is my y-intercept, there's this axis of symmetry. So the y-intercept is 3 units away from the vertex, so another 3 units away from your vertex is your symmetric point. And then we can draw our graph. A little far up. Okay. Why don't you try this one? Find the vertex on your own, and then plot it, and then unpause it, and I'll walk you through it. So to find the x value of the vertex, it's the opposite of b over 2a. So therefore the x value of your vertex is -1. So I have to find f of -1. So -1 squared is 1 times 2 is 2, -4 minus 1. So that's 3. So my vertex in this case is -1, 3. So I'll plot my vertex, -1, 3. And then my y-intercept is 0, -1. And then I can do my symmetry. Oh, here we go. My vertex is actually -1, -3. Do you know how I caught my mistake? It was opening down. It's supposed to open up. So be conscientious when you're doing it. Make sure that you don't make those silly mistakes. Obviously, it's pretty easy to do. And then I have this symmetry point right there. If I wanted to, I could find x-intercepts, but I don't need to. I just have these 3 points. That's all they were asking me to do, and then graph it. So again, when you're sketching that graph, making sure that you have a few points with those characteristics. Onward. Factored form. So factored form is the last form. So we have vertex form, we have standard or general form, and then we have factored form, also called intercept form. So factored form is really helpful because it automatically gives you some important information. They give you the hardest part to find in a quadratic. So factored form is f of x equals a times the quantity x minus p times the quantity x minus q. Now you're not going to use factored form a lot, but when you are given it, use it to your fullest advantage. So in factored form, what I automatically know are my x-intercepts. So the x-intercepts, we make y 0. So I do the zero product property, a equals 0, false statement, x minus p equals 0, therefore it's p 0 and q 0. Because I just set my factors equal to 0. We talked earlier to find the vertex, the x value of your vertex is halfway between these two. So average them. So to find the x value of your vertex, average the two x-intercepts. And I don't know what this one is, what my y value is. It's f of whatever this is. So once you get your x value, plug it in, you'll get your y value out. And then of course your axis of symmetry, just like before. Once you know that vertex, it's just x equals. So in this case, the average of those. So I hope that you're not trying to memorize, okay, this is this, and this is this, and this is this. Logically think through it. Intercept form. They're giving you the x-intercepts because it's factored. So you instantly can find your x-intercepts. If you know your x-intercepts, you can average those. If you really wanted, you could rewrite this out into standard or general form and do a different form that way as well. It all works, but I want you guys to practice using these key features because it's going to make graphing them much quicker, especially when time is of the essence. The quicker you can graph these, the more time you'll have to spend on some of the problems that maybe stump you a little bit more. I'd hate for you to spend a bunch of time on something that you already know. So in these two problems, now we're going to practice graphing these that are in intercept form. We're going to find the equation for the axis of symmetry. We're going to find the x-intercepts, the y-intercept, and the vertex. So we're going to find our 4 features in addition to our symmetry point. Okay, so right from the beginning, if I'm trying to find my x-intercepts, again, we make y 0. And we set our factors equal to 0. That's the zero product property. So my x-intercepts for this problem are 4, 0, and 2, 0. So those are my two x-intercepts for this. 4, 0, and 2, 0. Then if I want to find my vertex, I have to find halfway between those two. So I'm going to average them. 4 plus 2 divided by 2. That gives me the x value of my vertex. So 6 over 2, so it's at 3. So now I have to calculate f of 3. So plugging that in, I get 3 minus 4, so negative 1 times 1. So that's negative 1. So therefore my vertex is 3, negative 1. So 3, negative 1. They also asked me to find my y-intercept. When it's in this form, my y-intercept is not easy. The only time that one's easy is when it's in standard form. Standard form is the hardest one to find your vertex in. There's pros and cons to each. So if I want to find my y-intercept, I'm going to set x equal to 0. So this is 0 and this is 0. So I get negative 4 times negative 2, which is at positive 8. And that's, let's see, my vertex is at 3. So it's 3 units away from my vertex, so another 3 units away at 6. There is my symmetric point. And now I can go ahead and graph. Oops. And there's our parabola, more or less. Okay, last one, practicing this. Now I'm giving you an a value as well, but everything's still done pretty much the same way. I'm just going to slide this over to give myself some space. Okay, so x-intercepts. If I set my factors equal to 0, so my x-intercepts would be negative 3, 0, and negative 1, 0. To find my vertex, why don't you pause this? Go ahead and do this. Vertex, average them, add them together, divide by 2. So the x value of your vertex, negative 4 divided by 2 is negative 2. Therefore, find f of negative 2. So that's negative 2 times 1 times negative 1. So that's at positive 2. So therefore, my vertex is at negative 2, 2. And I'm going to go ahead and plot these. So negative 2, 2. And then I have the two x-intercepts at negative 3, 0 and negative 1, 0. And then my y-intercept, set my x is equal to 0. So I have negative 2 times 3 times 1, which is at negative 6. And then symmetry. And connected opens down. It has to open down. It had a negative a value. And there's your parabola in vertex form. I'm sorry, in intercept form. So let's recap. There's a lot. We just went through a lot of different things. Hopefully you're remembering this and it's coming back and it's familiar. If any of these forms are a little harder for you, take some extra time on them. I'm not assigning all the problems by any means, but this is going to give you a good idea of each of the different types. So there's 4 of each type of practice problem in your homework, and then there's one that's just a mix of any of them and you don't know which one's which. I'm only assigning 2 from each of the sections, so don't be afraid to do an extra one if you're not confident with it. So here's general form, also called standard form. So here's what we have. That's our equation. It instantly gives us our y-intercept. To find our axis of symmetry, we need to find the fact that we know our vertex, which is from down here. Okay, opposite of b over 2a always gives you the x value of your vertex. But the y-intercept is the only thing it instantly gives you. When you have it in vertex form, it instantly gives you your vertex, and then you've got to find your other information. Intercept form, it instantly gives you your x-intercepts. Once you have your x-intercepts, finding your vertex isn't too difficult because you just have to average them. And that's what we did a lot in Algebra 2 with the vertex form, is we'd find our x-intercepts and then we average them to get the x value of our vertex. So working through these, making sure that you're comfortable with them. Keep in mind, if a is greater than 0, it opens up. If a is less than 0, it opens down. Because if it's greater than 0, it's concave up, there's a min. If it's less than 0, it's concave down, there's a max. So these are all the different forms for graphing. The last thing that we're going to go through is taking the form that we have and writing it into another form in addition to finding key characteristics. So without graphing now. So being able to use this function to be able to rewrite and then also to find whatever important information we have. Because a lot of times we'll graph it and then we can kind of see that information, but sometimes it doesn't make sense to do that. So what we want to do is we want to write each of these into factored form, in an intercept form. And then once we get into intercept form, then we'll have our A, our P, and our Q, and we're going to list each of those out just to make sure we have the right negativities for each of them. And then we're going to also write down the X and Y intercepts, so that way we have all of our information for everything. Okay, so step one. If I want to get this into intercept form, I need to find my intercepts. How do I find my intercepts? It's factored. Now, one of the things that you'll notice with intercept form is that coefficients on X are 1. So if there is a leading coefficient, you have to factor it out of everything. Now, sometimes it might be easier just to factor, but please keep that in mind. A in intercept form is the same as A in standard form. Let's go back here. Do you see how all of these have an A? It's the same thing. So if you have something in general form, it has to be factored all the way outside of it. Okay, same thing with vertex form, etc. That is the nicest parameter. General form, you have your B, you got to find your y-intercept. Vertex form, you have to find your vertex. And then intercept form, you find the 2 intercepts. But keep in mind, we're not going to have factors that are integers when we do this. And that's a little different than when we factor. We have to have integers. So keep that in mind when you're going through that process. So I'm going to find my 2x intercepts. So I'm going to factor this. And I get x plus 8 and x minus 2. Therefore, my 2x intercepts are -8, 0, and 2, 0. Now that I know my 2x intercepts, I can write this instantly into intercept form. So f of x equals, my a value was 1, so I don't have to write that, x minus p, so x plus 8 times x minus 2. So a is 1, p is -8, and q is 2. It doesn't matter which one's p, which one's q, it's the same thing. And then they also wanted me to find my y-intercept. My y-intercept, because it's in standard form, pretty easy, 0, -16. Okay, for B, two options for you. You could factor this, but if you factor this, you're not going to get it exactly into this form. So you're going to do a form of factoring, but you're going to specifically solve for your x-intercepts. So make f of x 0, and we're going to solve it, in essence, by factoring. So I'm going to go through and I'm going to factor out. It's up to you how exactly you want to factor this out. I know that there's an x I can factor out, and I know there's a -2 maybe I want to factor out. You could factor out a +2, you could factor out a 4. There's a few different options, but I want to show you what this looks like. Okay, is that good so far? Really, the important thing is you got the x out. So I factored out the greatest common factor. So I legitimately factored this. So now I do the zero product property, which gives me my x-intercepts to be 0, 0. And set this one equal to 0, that's a half, 0. Again, I just set each of those factors equal to 0. Once you know those x-intercepts, just like you did over here, now you can write your equation. F of x equals x minus 0, x minus a half, and then my a value, which is -4. Sorry, it's a little cramped in there. Which gives me a to be -4, p to be 4, and q to be a half. Okay, so that's going from standard form to intercept form. Once you know your x-intercepts, it's pretty straightforward to put it into that form. The next one, we're taking intercept form and we're writing it into standard form. So we're going vice versa on this one. So for A, we're going to go vice versa. So if I want to find this in standard form, I need to find my y-intercept, and then I also need to figure out what my a and b are. So, and then also they wanted what my x-intercepts. Okay, so let's do x-intercepts first. X-intercepts would be 1, 0 and -2, 0. Right, in intercept form, you can find them right away. My y-intercept plus 0 and for x. This is 0, this is 0, so I have 3 times -1 times 2, which is -6. So that's 0, -6. Okay, so let's go back to the problem. They want me to put this in a standard form. So I really just need to rewrite it. So I just need to rewrite this to get it into standard form. So f of x equals 3 times, expanding that out, is x squared minus 1x plus 2x, so plus x minus 2. Triple all those values, so you get 3x squared plus 3x minus 2. Poof, done. And then my a is 3, my b is 3, and my c is negative 2. So based on what they wrote here, those are the 3 parameters. In part B, a little different. This one's in vertex form, and they want us to write this one also in standard form, and then find the a, b, and c. The coordinates of the vertex, so let's start with that. So in this form, what's my vertex? 4, negative 2, because remember it's the opposite of x, and then it's just what y equals. And then the y-intercept, I've got to plug 0 in. So substituting 0 in, I get 16. So times negative a half is negative 8, minus 2 is negative 10. So therefore my y-intercept is 0, negative 10. Okay, so now I'm going to rewrite this into standard form. Again, just like before, I'm just going to have to show my work and expand. Putting it into standard form is probably the most comfortable form to write it into. So f of x equals negative a half, and then squaring x minus 4, so x minus 4 times x minus 4, so x squared minus 8x plus 16 minus 2. Send through that negative a half, so negative half squared minus, plus 4x minus 8 minus 2, which is negative a half x squared plus 4x minus 10. Double check, we found our y-intercept. It is the same. So my a is negative a half, my b is 4, and my c is negative 10. So again, just being comfortable rewriting it from any form. The last thing that we're going to do is we're going to look at an equation and write our graph or write our equation from that. So you're going to have to pull the information out. So instead of them telling you, hey, this is this and this is this, what you're going to do is you're going to take this information and we're going to write our final answer in general form. And that is a very typical question. Here's some information, rewrite it in this form. Now, a lot of times you're not going to start with it in that form. You're going to start it in another form. So for instance, here, if you look at what they're giving you, what information are they telling you? The x-intercepts, right? So this one, it makes sense to write an x-intercept form and then solve for your last parameter, that last parameter being a. Sometimes you can see a, sometimes you can see your stretch factor, other times not. In B, what do they give you here? The vertex. So this one makes sense to use vertex form. It's really hard to directly write anything into standard form. The only thing that you might know is C. Otherwise, you don't know anything. So keep in mind, most likely you're going to start in a different form and then you're going to move it into standard form. So why don't you go ahead and pause this and set up your equations. I'll work each of them through, but set up each of your equations to see if you can do it without me doing it first for you. So for A, it's f of x equals, I don't know my stretch factor, and then x minus a negative 4, so plus 4 times x minus 3. Now I have to find my parameter. So in order to find my parameter, I have to substitute in a point that's on here. They gave me this point. So negative 24 goes in for your y, a, and then 0 goes in for x, and 0 goes in for the other x. Because it's the point 0, negative 24, not just because I'm plugging it in. Like, that's my x value. So this gives me negative 12, divide negative 12 over, so a therefore is positive 2. So your equation in intercept form is f of x equals 2 times x plus 4 times x minus 3. I still have to multiply this out and get it in a standard form. Again, it makes sense to get it into this form, then you just have to expand out. So 2x squared plus x minus 12. So that's then 2x squared plus 2x minus 24. That is general form or standard form. Okay, then part B. For part B, this is our vertex form. So f of x equals a times the quantity x minus my vertex, so the x value of my vertex is 2 squared, and then the y value says minus 2, so subtract 2. Again, I've got one parameter left to solve for, so I'm going to plug in a coordinate point. Again, this one they happen to give me my y-intercept, so the x value is 0. They don't always. It could be any point that they give you, but you have to mathematically solve the equation. So 4 equals a, and then this ends up being 4, because 0 minus 2 is negative 2. Negative 2 squared is 4, minus 2. Be careful order of operations. You got to add that 2 over to both sides. So therefore, you have 6 equals a times 4. Divide both sides by 4. A therefore is 3/2. So in vertex form, f of x equals 3/2 times the quantity x minus 2 squared minus 2. If they just said write an equation for this, you'd be good, you'd be done. However, they did not. They asked you to put it in standard form. So I got to go one step further. And part of the reason they do that is it makes it easier to grade the answers, making sure that you get to the final correct answer. So this is x squared minus 4x plus 4. That's that quantity squared. Minus 2. I got to do the multiplication first. So that's 3/2 x squared minus 6x plus 6 minus 2. So standard form, 3/2 x squared minus 6x plus 4. Okay, great job. So that is your standard form. So now you're going to go through and practice. You're going to go through and practice graphing all the different types of functions. So graphing them in each of the forms, and then also just being comfortable moving the different forms around. So your homework for this content is 3m, 1ac, 2bc, 3ad, and 4. Keep in mind for each of these, I just picked 2 of the 4 to give to you. If you need extra practice on each of the different types, just do more of that kind. Each of you are going to be a little different based on your comfort level. And then for 3n, you are just going to do 5. That's a small one. And then 3o is 1abf, and then 2. Okay. Work on these quadratics. Hopefully this is making sense since it's stuff that you've done before. Don't be afraid to reach out if you need help.